Alright, let's go. Advent of Code Day 2. Let's see what the problem we got is. Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? Okay. As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play the game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once the bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game. Each game is listed with its ID number, like the 11 in Game 11, followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. In Game 1, the 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes and 4 red cubes. The second set is 1 red cube, 2 green cubes, and 6 blue cubes. What? The first set is 3 blue cubes, 4 red cubes. Oh, okay. Oh, separated by a semicolon. And then 1 red, 2 green, 6 blue, semicolon, and then 2 green. Okay. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. In the example above, games 1, 2, and 5 would have been possible if the bag had been loaded with that configuration. However, game 3, 20 red wouldn't have been possible. And 13 green is barely possible. Would have been impossible because the elf showed you 15 blue cubes at once. If you add up 15 blue cubes? Oh, game 4. Yeah, 15 blue. Okay. If you add up the IDs of the games that would have been possible, you get 8. Okay? Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? Okay. This doesn't seem too hard. Need to be able to okay, yeah. So you basically need to be able to parse these lines into meaningful information. And I think it's pretty much just if at one time you're shown more than 12 red, 13 green, or 14 blue, then that game is impossible. Okay, let's get to work on this. Oh wait, hold on, let's get our input. let's do some test input so that we don't have to go through this whole big thing every time. Okay. All right. So where do I start? Well, I guess I start the same as I did yesterday. Let me actually just go and yoink some code from day one here. Oh, whoops. I actually need to copy that to clipboard. Okay. So I need buff.io and I need OS. Okay. All right, so in air equals read lines. Test if air is not equal to nil, then format.println air os.exit 1. Import that. For line in range of n, just print it out. Oh, I'm in. Yeah, that was confusing. Okay. Okay. So we got our input loading in. Okay. So okay, so I just need a sum variable to keep track of the sum, obviously. So let's see here, sum equals 0. I need to okay. So I don't think I need to get all the information from every line. I can just write a function that returns the game and then the maximum number of each color shown at once. And then from there, I can use that to, from there I can just check if the maximum number that any color was shown at once is higher than the number for that color. And actually, okay, let's get some constants in here. Max blue, I think, was it 15? What is the maximum number of everything? 14 blue, 13 green, 12 red. Okay. I should do this in like RGB order. Okay. So I got some constants. They are the correct constants. Okay. So let's make a function called parse lines. Takes in a line, which is a string, and then it will return int, 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 int. And I'm thinking that this order will be the ID of the game, red, green, blue, or like the maximum value of red, maximum value of green, maximum value of blue. Okay. Not const. Okay. So let's go. Yeah. Let's just initialize all of those to 0 so that if there's none, I get an accurate result. Okay, so ID is going to be the parsed int of everything between 0 and the colon. Or not 0 and the colon. Everything between the end of the word game and the colon. So let's see, how easy is it to get that? Okay, so we've got I guess I just get the first index of space, add 1, and then go until the colon. Alright, there we go. Just wanted to add those to Harpoon so I can hop back and forth between them. Okay. Okay. So string ID equals yeah, I could you can just okay, so equals line, or is it like strings dot index line space, right? Whoops. How do I? Okay, there we go. Got it. Index returns the index of the first instance of the substring. Okay. So equals line from there. Wait. Hold on. I'm trying to remember how this works. Give me 1 second. Yeah, okay, there we go. So I need line from there to strings dot index of the colon. Okay, and then ID is equal to strconf.ahui string ID. Okay. So let's just do a sanity check. Make sure I'm getting everything right. Format at print line. Hold on. ID, red, green, blue, equals parse line. Let's rename this because I don't know why I called it parse lines if I'm only doing one line at a time. And then format.println ID, red, green, blue. And let's just do sum so I don't get an error that sum is unused. So this should be whatever the ID is and then a bunch of zeros. That's what we're expecting to see. Instead we get a bunch of zeros. Let's print the error if we get an error. Ah! The space is throwing it off because I forgot to do this little +1. All right, there we go. 1, 2, 3, 4, 5, and a bunch of zeros. Awesome. Okay. So now, God. Now I guess I need to get, what, everything after the colon until the comma. Everything after, Yeah, I wish they, I understand why they did it, but it's not really, I don't really need the different pools separated by a semicolon for the solution, at least not to part 1 here. All right. Okay, so let's see. Maybe I can split it. Hmm. Trying to think of ways to do this that won't completely fuck me if part 2 is completely different. Alright, I'm going to take a quick break to walk my dog. I'll be right back. Okay, I'm back. So I had a thought on how to parse this. So my problem before I left was that I wanted to figure out how to parse this in a way that wouldn't require a rewrite if part 2 cares about the individual pools. And so I think oh geez, they don't pool the same amount every time. Oh wait, no, but that's fine. I can just split. Okay, yeah. So what I came up with was that I'm going to chop off the front bit here. Like I'm going to just chop off at the index of the semicolon plus like 1 or 2. And then I'm going to split on semicolons. And then I'm going to iterate that through that, splitting on like comma space and parse from there. And I guess from there I like split on the space and then I have the number and the color. So yeah, that's my plan. Let's get started on that. Okay. So let's see. Line equals line strings.index of the colon onwards. And let's just see what that gives me. Okay, so I need to add 2, I think. Okay, there we go. So now pools equals, is there a split? There is. So I want to split along the semicolon space, right? Whoops. Yeah, I want to split along semicolon space. So for string in pools, okay. That looks good. Okay, and now for each of these, I split on the space. Actually, yeah, maybe I make a map. I know I used a map last time, but they're really just so useful. So I think what I want to do is I want to make a map rather than have these three red, green, blue variables. I want to have max color, or okay, max is a function. Let's just call it like MC for max color. Okay, I gotta go check on the dog real quick. Okay. Alright, so I want a map that is max colors. So make this a map. String int. And I want it to have some initial values of red 0, green 0, blue 0. Okay. So now let's record a macro. Oops. Oh, geez. There we go. Okay. All right. So now this makes it easier to just like say, hey, put this thing here. Okay, so for each pool, let's actually change this to pool. For each pool, I want like colors equals split on the comma space. Okay. And then for underscore C in the colors. Okay. I want to split it on the space. Yeah. So I do all right. Yeah. I do what do I want this variable to be called? Cubes, I guess. Cube. Split that on space. Okay, so now this should be All right, let's just see. Am I getting the right output? Am I? Okay, perfect. Yeah, I'm getting each individual little thing. Awesome. Okay. So now the rest of this should be pretty easy. So 0, like the first element of this cube is the count, and the second element is the color. So now, the cube, strconv a2i cube 0. Well, hold on. Let's make these more readable. Count equals cube 0, color equals cube. Do I keep typing 2 there? Cube 1. And actually, I want this to be and I need okay. So I have count and color. If count is greater than max colors, color, max colors, color equals count. Okay. Yeah. That looks good. Let me just, let's see. So we have 4 to 6, and that's an RGB order. So 4 for red, 2 for green, 6 for blue. Okay, perfect. Okay. So we are now accurately parsing each line. If I need to in the second round, then I can worry about the individual pools. So yeah, this is working. This is working nicely. Okay. So now. I want to pull this out into a function just because I don't want to. Let's do func possible. All right, those are all ints, and this returns a bool. Okay, let's go and grab these, put them up here. If red is greater than max red, wait, return red less than max red, and green less than max green, and blue less than max blue. Okay. So, if possible red, green, blue, then sum plus equals ID. and then print out the sum. 8. Okay, so that is working, because if you remember, it says for this test data, if you add up the IDs of the games that would have been possible, you get 8. So that's good. That means that this is working. So let's run it on the actual data set now. $1,178. Let's see if that is correct. It's not the right answer. Your answer is too low. What? Okay, so hold on. Let's do some debugging. Let's actually do it like that. Let's get rid of this print statement up here. Okay, so 100 should have 15 for the maximum red. Yeah, so here's 15 red. There's no higher red count. Oh, I should also have whether or not it's possible. And just so no. Okay, so let's see here. So game 1, 1, 19, 7, 8, false. Not possible, sum is 0. 17 is too high. And is that the correct value for green? Yes. So it's false and 0. Why is it not that answer? What's wrong? Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? Like, it's not this. That's wrong. Your answer is too low. Am I using the full input data? Yeah, I'm using all 100 games. Huh. It's too low. Oh. I figured out the problem. This needs to be less than or equal to. I need to remove my print statements. There we go. Okay, that looks like a more correct answer. What? Huh? $12, $13, and $14. Oh my god. How did that happen? Okay. Somehow the max numbers got mixed up. Okay. That is yet another bigger number. Six seconds left to wait. Okay. There we go. Okay. Part 2. The elf says they've stopped producing snow because they aren't getting any water. He's unsure why the water stopped, however, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Okay, so in game 1, the game could have been played with as few as 4 red, 2 green, and 6 blue cubes. If any color had even one... Oh. Alright, so game 2... This seems easy. I'm pretty sure I already have the answer to this. The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48. Games 2 through 5 was 12, 15, 60, 16, 30, and 36 respectively. Adding up these 5 powers produces the sum 2286. For each game, find the minimum set of cubes that must have been present, and then sum the power of the sets. Okay, well, this is easy. Like, I'm already getting... Like, I have half the problem done already. The hardest part of the problem is done already. Because I'm getting the maximum color shown from the pools. Okay, so let's leave all this untouched just for posterity, because that is something I'm upset about yesterday, is that I sort of muddled what my solution to part 1 was when I was solving part 2. Let's create power sum, set it equal to 0, and then, oh, okay, but I'm not, okay. Let's real quick type game. I'm just going to create a struct real quick to hold this stuff in. All right, no commas for these, forgot. Okay. And then let's create a list of these games. And then games equals append games. Okay. So now for game, all right, for each game in games, yeah, so I have the, like I already have the numbers that would make it possible. Because I have the maximum number of cubes that showed up in the game, which is the minimum number to make the game possible. So now I need to just multiply red, green, and blue together and sum them. So power sum plus equals power sum plus equals game dot red times game dot green times game dot blue. Let's do this on the test input so I can verify that it works. I got 2286. Okay, yeah, that is correct. Okay, so 75,513. I mean, I see no reason that shouldn't be correct. That's correct. Okay. Yeah, so part 2 was actually way easier than part 1. That's crazy. All right. So, yeah, I am pretty happy with my solution here. I'm glad I had this function that was just returning what I needed. Like, I'm glad I structured this in a way that made part 2 trivial to implement. Because I very easily could have structured this in a way that would have made part 2 a little bit harder. All right, well, Thanks for watching. Check back in tomorrow for day 3. Alright, so I figured I would record this little segment and put it on the end here to actually properly explain what I'm doing with the solutions. Because I realize my just stream of consciousness as I'm working on the problem isn't necessarily going to tell you everything you need to know to understand the code here. So I'm going to start by explaining my solution for part 1, skipping over any parts that I may encounter along the way that are for part 2, and then I'm going to explain part 2. Okay, so let's just start in the main function here. So first of all, this line, I am getting the input from readLines, which is this function that I defined up here at the top, this readLines. And this just opens the file I tell it and gets every line of that file and puts it into an array of strings, with each element of that array being one line. And then if that causes an error somehow, like maybe I put in a file that doesn't exist here or something, then it'll tell me about the error and exit. This line is for part 2. So, all right, down here, I declare a variable to hold the sum. And then for every line in the input, so this will just loop over. It'll repeat this same thing for every single line in the input. I get the ID, the highest red value that showed up, the highest green value that showed up, and the highest blue value that showed up from my parseLine function. And what this function does is it just, I create a map that has red initialized to 0, green, it has red, green, blue all initialized to 0. Let's see, and then down here, this is me, this block of code here is just getting the ID. So I'm going to the first space, which if we go to our input, the first space in every line is after game. So I'm going to the first space plus 1, which will be the start of the number. And I'm going until the colon, which will be at the end of the number. And the reason I have to do it this way is because if we go to the actual input file, you can see, these numbers can be more than 1 digit. So you can have two-digit numbers, and then at the very end there's a 3-digit number with 100. So I can't I have to use, I have to use what I always know is going to be on either side of the number to figure out where the number is. But yeah, so I grab the number from that, and then it's a string. When I do that, it's a string, so I need to convert it to an integer. And that's what this line is doing. And then this line is just checking for any errors in that conversion. And if it does, then it just returns all zeros, which I figured I should do because I figured returning all zeros would work because it wouldn't affect the sum or anything. It wouldn't break anything. Let's see. So after I do that, then I just trim off. All this line is doing is it is just chopping off this front part here of the line. Is chopping off everything up until the first number of the line. And that just makes it a little bit easier to work with so that I can do what I'm about to do next. So next up, I split every pull from the bag. So every time they pull from the bag, the way that's formatted in the input is they separate it with a semicolon. So I'm like, okay, let's split on the semicolons, and all this split does is everywhere there's a semicolon, that is going to be deleted, and it's going to put everything on one side of that into an element of an array. This is going to be the next element in the array, and then this will be the last element. So like it just creates an array and, you know, creates elements with whatever separator you put in as the boundary between each element. So after doing that on this line, I'll have one element that's this 3 blue, 4 red, a second element that's this 1 red, 2 green, 6 blue, and then a third element that's just this 2 green. So that gets me all the different pools. And then I called this variable colors because I couldn't think of a good name in the moment, but this is each of these, like this is a pair of a number and a color. Like I'm splitting on the comma this time, so I'm just going to have 3 blue and 4 red, for example. So yeah, I am just getting those pairs, and then I'm splitting those pairs on the space so that I have 2 elements, and I know, okay, this first element is the number, the second element is the color. And now finally, I convert the first element, that's the number, to an integer, because it's just a string that is a 1. It's not actually a number yet. So I convert it to an integer. And then, because I made the keys for our map the colors, I can just say, set this color to this count if it is higher than what's already in there. And this will ensure that I get the highest number in that row for that color in the correct place. So like, for example, if it's going through here, it gets this 3 blue. So on the first pass, you have to remember that blue is 0. So on the first pass where it hits this, then it will be like, okay, that is currently the maximum. So blue is 3. 3 is the highest number of blue we've seen so far. And then it goes through a bit later, goes through this 4 red, it goes through this 1 red, goes through this 2 green, and it comes back, it sees, okay, we're looking at blue, and this one is 6. 6 is bigger than 3. So because 6 is bigger than 3, I am going to update it so that my maximum count for blue is now 6. So that's basically all that's doing. And then I just return the ID and the counts for each color. So that's all that this line is doing. This line is getting the ID and then the counts for each color for each line. This is for part of the solution for part 2, so I'm just going to skip it for now. Possible, this function, all it does is compare the... all this function does is compare the numbers I passed in with the maximum allowed numbers. So they have to be less than or equal than the maximum for it to work. And it just says all 3 of these conditions have to be true. Otherwise, it's not possible. And then if it's possible, then I just add the ID to the sum. Okay. So now part 2, what I did for part 2 is I wanted to go through, I realized that I was already getting, like these red, green, and blue values are already the numbers I need for part 2. Because the maximum number that shows up in each game is the same as the minimum number in the bag for that game to be possible. So... yeah, so I wanted to be able to reference all the games, so I created this struct that represents a single game. So it has the ID of the game, the red, green, and blue value, and then I created this slice of games, so that I could just store each game as they come in. So each time I read a game, each time I parse a game, I append it to the slice. And then down here, I just calculate the power sum, which the problem definition gave us is just red times green times blue. And like the power of the game is just red times green times blue. And I just add the powers of all of the games together to get my final answer for part 2. So that's how it works. Hopefully that all made sense. Yeah, I just wanted to go through and try to explain in more detail.